Hello everyone, my name is Geraldine Isabel Manalu, student ID number 2023-32016. In this video, I will explain the results of my blockchain technology practical project entitled Digital Training Certificate Verification System based on Ethereum using blockchain smart contract technology. This project was developed to address the problem of digital certificate forgery, which is still a common issue today. Conventional system certificates are usually stored as PDF files or images that can be edited or manipulated. Therefore, this project utilizes Ethereum blockchain technology to store certificate data securely, transparently, and immutably. In this project, several tools were used, including Remix IDE for smart contract development, Solidity as the smart contract programming language, MetaMask as a digital wallet for blockchain transaction, Ethereum Sepelia testing as the testing network, and Etherscan as a blockchain explorer to monitor and analyze transactions recorded on the blockchain. The smart contract used in this project is called certificate system. It was developed using Solidity and servers as the core component for managing digital certificates. At the beginning of the smart contract, there is a certificate stack which is used to store certificate information such as the certificate ID, recipient name, course name, issue date, product status, and user address. These data are stored using a mapping structure, allowing each certificate to have a unique key identifier and be accessed through its certificate ID. The first main function implemented in the smart contract is create certificate. This function is used to issue a new digital certificate on the blockchain. When this function is executed, the user enters the recipient name and the course name. Since the function modifies blockchain data, the transaction must be confirmed through MetaMask and request gas fees. After the transaction is successfully processed, the certificate information is permanently stored on the Ethereum Sepelia blockchain network. After the certificate is used, the transaction can be viewed through Etherscan. On the Etherscan page, the transaction status is displayed as success, indicating that the transaction has been successfully processed by the blockchain network. Additional information such as the transaction hash, block number, sender address, contract address, and transaction fee can also be viewed. These details serve as proof that the certificate data has been successfully recorded on the blockchain. The next function is verify certificate. This function is used to verify the authenticity of a certificate that has already been used. The user only needs to enter the certificate ID, since this function only reads data from the blockchain and does not modify any information. It does not require gas fee or MetaMask confirmation. During testing, the certificate was successfully verified and the system returned a valid status. Another function test in this project is get certificate. This function retrieves detailed information about a certificate stored on the blockchain. The information displayed includes the certificate ID, recipient name, course name, issue date, certificate status, and user address. The testing result showed that all certificate data were successfully stored and could be retrieved correctly. In this practical project, the revoke certificate function was also tested. This function is used to revoke a previously used certificate. After executing the function and confirm the transaction from MetaMask, the certificate status changed to inactive. To verify the result, the verify certificate function was executed again and system returned in invalid status. This demonstrates that the certificate revocation mechanism works correctly according to the system design. In addition to the main function, the smart contract also provides supporting functions such as authorize user and revoke user, which are used to manage certificate issue permission. This function allows administrators to grant to or revoke issuing rights so that only authorized parties can use the certificate within the system. Furthermore, the smart contract includes certificate count, owner, and authorized issuer, which support system administration and access management. Based on the practical implementation and testing result, it can be concluded that the certificate system smart contract deployed and executed on the Ethereum Sequoia testnet. The system is capable of issuing digital certificates, storing certificate data permanently on the blockchain, verifying certificate authenticacy, and revoking certificate when necessary. By utilizing blockchain technology, the system provides higher security, transparency, and data integrity compared to conventional digital certificate management system. Thank you for watching this presentation.